Sensor Fusion AI. Here is your same structured beginner-friendly content for Sensor Fusion AI, Beginner Level, Introduction. Sensor Fusion AI means using artificial intelligence to combine data from multiple sensors to create a more accurate and reliable understanding of the environment. In real-world systems, relying on a single sensor can be risky because sensors can fail, data can be noisy, information can be incomplete. Sensor Fusion solves this by combining multiple sources like cameras, radar, LiDAR, GPS, temperature sensors, motion sensors. Examples include self-driving cars combining camera plus radar plus LiDAR, smartphones using GPS plus accelerometer, robots using vision plus touch sensors, smart homes combining motion plus light sensors. This topic helps beginners understand how AI improves accuracy and reliability using multiple sensors. What is Sensor Fusion AI? Sensor Fusion AI is the process of combining data from multiple sensors using AI to improve decision-making. In simple words, Sensor Fusion AI equals using many sensors together to understand better. Key idea. Instead of one sensor means limited information, AI does combine multiple sensors, reduce errors, improve accuracy, make better decisions. Types of sensors. Sensor type example, camera, images and video, radar, distance and speed, LiDAR, 3D mapping, GPS, location tracking, accelerometer, motion detection, temperature, environmental data. Example of sensor data. Sensor data equals camera, car detected, radar, distance 20 meters, LiDAR, object shape detected. Of simple fusion logic, camera equals car, radar distance equals 20. If camera equals car and radar distance less than 30, print car nearby. Simple sensor fusion example, Python temperature equals 30, motion equals true. If temperature greater than 25 and motion, print human activity detected. How Sensor Fusion AI works. Step 1. Collect sensor data. Camera equals object. Radar equals 15. Step 2. Process each sensor. Print processing camera and radar data. Step 3. Combine data. If radar equals 20, print object is close. Step 4. Make decision. Take action based on fused data. Step 5. Execute action. Print action executed. AI in self-driving cars combines multiple sensors for safety. Camera equals pedestrian. LiDAR distance equals 10. If camera equals pedestrian and LiDAR distance more than 15, print stop vehicle. Robots use sensor fusion for navigation. Vision equals wall. Touch equals true. If vision equals wall or touch, print avoid obstacle. Phones combine sensors. GPS equals location. Accelerometer equals movement. Print tracking movement. AI in healthcare monitors multiple signals. Heart rate equals 110. Temperature equals 38. If heart rate in 100 and temperature in 37, print health alert. AI in smart homes combines environment data. Motion equals true. Light equals dark. If motion and light equals dark, print turn on lights. Full menu-based sensor fusion example. Def process camera. Cam equals input. Enter camera data. Def process sensor. Sensor equals input. Enter sensor data. Print sensor. Def fuse data. Cam equals input camera object. Distance equals int input enter distance. If cam equals object and distance less than 20, print object is near. Else, print safe. While true, print N1 camera input. Print 2 sensor input. Print 3 fuse data. Print 4 exit. Choice equals input, enter choice. If choice equals 1, process camera. If choice equals 2, process sensor. If choice equals 3, fuse data. If choice equals 4, break. Else, print invalid choice. Concepts learned. Check. Sensor fusion, check. Data integration, check. AI perception, check. Decision making, check. Real-time systems, multimodal AI. Real-life analogy. Sensor fusion AI is like a human using multiple senses. Click eyes, vision, ears, hearing, touch, feeling. Combining all gives better understanding. Ways to improve a project. Use real sensor datasets, combine image plus sensor data, use deep learning models, build robotics applications, add real-time processing, use IoT devices, integrate APIs, optimize performance. Common mistakes beginners make. Not using only one sensor. Not ignoring noisy data. Poor data synchronization. Overcomplicating fusion. Not handling sensor failures where it is used. Autonomous vehicles, robotics, smart homes, healthcare systems, industrial automation, IoT systems, security systems, AR, VR. Large systems may include sensor fusion engines, real-time AI systems, autonomous platforms, multimodal AI. Simple definition. Sensor fusion AI. The use of AI to combine data from multiple sensors to improve understanding and decision-making. Final summary. Sensor fusion AI enables systems to combine multiple sensor inputs, improve accuracy, reduce errors, make smarter decisions. It is essential for building reliable and intelligent real-world AI systems.